This week on BSD Now, we're covering byproducts of reading OpenBSD's netcat code, learnings from porting your own projects to FreeBSD. We cover OpenBSD's Unveil, as well as NetBSD's virtual machine monitor, which is brand new, and also what dependency means in Unix init systems, as well as jailing bhyve in this week's episode of BSD Now. BSD Now, episode 272, Detain the bhyve, recorded on the 14th of November 2018. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
Another week, another BSD Now episode. We start right into the headlines with the byproducts of reading OpenBSD's netcat code. So this is over at Nanxiao's blog, and the byproduct of reading OpenBSD netcat code is when I took part in a training last year, I heard about netcat for the first time. During that class, the tutor showed some hacks and tricks of using netcat, which appealed to me and motivated me to learn the guts of it. Fortunately, in the past 2 months, I was not so busy, so I can spend my spare time to dive into OpenBSD's netcat source code and got abundant byproducts during this process. First, brush up socket programming. I wrote my first network application just more than 10 years ago. I always think the socket APIs are marvelous. Just roughly 10 functions like socket, bind, listen, accept, and others with some I/O multiplexing buddies, select, poll, epoll, etc. Connect the whole world, wonderful. From that time, I developed a habit that is when touching a new programming language, network programming is an essential exercise. Even though I don't write socket-related code now, reading netcat socket code indeed refreshes my knowledge and teaches me new stuff. Number 2, write a tutorial about netcat. I am a mediocre programmer and will forget things when I don't use it for a long time. So I just take notes of what I think is useful. In my opinion, or in my humble opinion even, this tutorial doesn't really teach others something, but just a journal which I can refer when I need in the future. Number 3, submit patches to netcat. During reading the code, I also found bugs and some enhancements. Through trivial contributions to OpenBSD, I am still happy and enjoy it. Number 4, implement a C++ encapsulation of libTLS. So OpenBSD's netcat supports TLS/SSL connections, but it needs you to take full care of resource management, like memory, sockets, and all those. Otherwise, a small mistake can lead to resource leaks, which is fatal for long-lived applications. In fact, the 2 bugs I reported to OpenBSD are all related to resource leaks. Therefore, I developed a simple C++ library which wraps the libTLS and hope it can free developers from this troublesome problem and put more energy in application logic parts. Long story short, reading classical source code is a rewarding process, and you can consider to try it yourself. Hey, yeah, great.
I've definitely learned lots by just reading through source code for different things, whether it was the way ifconfig does some of the parsing and stuff when I added the CIDR support, or, all kinds of things in ZFS, although a lot of the ZFS stuff is well above my head. But looking at some of the more simple tools that don't change that much, you can see a lot of interesting bits. But at the same time, if you look at certain tools that were written a very long time ago and haven't been modernized, sometimes the way they do things is not necessarily the best way to do it anymore.
Yeah, which warrants a rewrite of certain parts. And I agree, start with an easy tool or relatively, easy to grasp source code, and then work your way up to more complicated tools.
Because there was another article we covered a while back where they were going through some of the basic tools and rewriting them, not for the purpose of replacing it, but of just the exercise of write your own implementation of cat. And then in the end, compare what you did to what the real one does. So don't look at the real cat first. Just take what you know about cat and make your own version. And then once it's all working and you're happy with it, then compare the source code to the original and see where it differs from your version. And that only really works with a really simple program where, there's not very many different ways to have done it. But
documentation usually works the other way around. You have the program and you should document what it does without even looking. But yeah, cool.
Sometimes to prove the point, what you should do is follow the documentation, implement what the documentation says, and then figure out what's different.
Oh, yeah, that too. But yeah, cool article. Try it out for yourself with the utility, and maybe you find interesting things there.
Yeah.
Okay, next up is what I learned from porting my projects to FreeBSD.
Yeah, so this is from a different user who's put up some code here on GitHub. And they say they set up a local FreeBSD VirtualBox VM to test some things, and it seems to work very well. Due to the novelty factor, I decided to get my software project to build on top of FreeBSD. So this is basically somebody's first time using FreeBSD, but they have their own software stack, and they had never considered making it work on BSD before, so they went through that process and documented it. So they talk about a couple of the different bits here, including they have a repo full of their dot files and some CPAN modules and some other bits. And they say, my project is written in a mix of C, Perl, Python, Ruby, Bash, XML, CMake, XSLT, XHTML5, and XHTML1. Wow. And website meta language and JavaScript. That's an awful lot of stuff. So, the basics of what they actually learned, though, is that FreeBSD on VirtualBox is very reliable. It survived a host power interruption. So actually, I guess a paused VM survived across the reboot of the host. They also mentioned that years ago when they tried it, rebooting with X running, because input was not enabled, would mess up etc directory or something. They say some executables on FreeBSD are in user local bin instead of user bin. Yes, that's not so much just some or anything that's not part of FreeBSD. Anything you install from a package is in the user local bin directory. So everything that you installed that didn't come with FreeBSD is in the local subdirectory. And I mentioned the higher man page that explains the directory hierarchy. Another thing they ran into is that the make command on BSD is BSD make, not GNU make. And so sometimes won't like your GNU make file. So one thing you can do is install and use gmake, and that will give you the GNU version of make.
Yeah, that's different.
The other thing is if you have a make file that contains GNU only stuff, you should really name it GNU makefile rather than makefile. And then this way you won't get the random errors. You will get told, you need to use gmake to compile this. In order to try to commonize it, they actually aliased the gmake command on their Linux machine so that they will be able to call gmake every time, and either that's make on Linux or gmake on FreeBSD. They also found out that M4 on FreeBSD is not compatible with the GNU M4. So they added this commit to first check if there's a gm4 command, and if there is, use that, and if not, fall back to the local M4. They also say some CPAN modules fail to install using the local lib directory. No idea why. But they just installed the FreeBSD package instead of using the CPAN module. And again, the docbooks XLS files are under user local share SGML instead of user share SGML. And apparently FreeBSD's grep does not have the -P flag because -P is not part of POSIX grep.
Okay, so that's a GNU extension.
They also found that FreeBSD does not have the nproc command to tell you how many processors you have. We might maybe just add a simple tool that does that just reads the hw.n CPU or whatever it is to tell you how many CPUs you have. It might be worth doing that.
That should be an easy program, referring to the previous headline.
Right, like it's literally read a sysctl and print out the value.
Yeah, some error checking around, and then that's all.
it would be a really good beginner program.
Submit patches.
Yeah, and I've also sometimes wondered for something like LSBLK for listing block devices. It might make more sense to just make a package of these little helpers and be like, Linux helper programs or something.
Yeah, for people migrating.
Yeah, because
or porting.
There's not necessarily a great way to get a list of all the block devices in FreeBSD. Because you've used like cam control dev list that assumes some things like certain NVMe devices don't show up there, certain special RAID devices don't show up there. The current
but the CD drives show there.
Current disks shows a bunch of things, but it just gives you the device name. It doesn't tell you anything about it, and so on. And it might be nice to have a tool. I might even name that something different and more FreeBSD specific, but
yeah,
like disk stat or something.
Disk list,
something like that.
LS disks.
Anyway, getting back to the start. So they made a little wrapper script for nproc that uses this ETL and figures out how many cores you have. Things that they didn't get working were the valgrind tests still fail, possibly due to a bug, and the spell checking test fails because apparently Hunspell has system-dependent dictionaries, and so it's not matching what the test was written to expect. And then they have an interesting conclusion, a quote from Larry Wall, one of the original authors of Perl. It is easier to port a shell than to port a shell script.
That's saying something about the shell scripts, yeah.
Yeah. This is, I ran into some cases where my scriptology was lacking and suboptimal, even for my own personal use, and fixed those. And they also have links to where this story was discussed on subreddit or on the FreeBSD subreddit and on Hacker News.
Oh, okay. Very nice. Yeah, porting definitely is a good way of getting more exposure to your program on other platforms, or it might open up to a whole lot of new users that you've never would have imagined would use your software just by porting it to a different architecture or platform.
Mm-hmm.
So, time for News Roundup. This week, we have OpenBSD's Unveil for you. And one of the key aspects of hardening the user space side of an operating system is to provide mechanisms for restricting which parts of the file system hierarchy a given process can access. And Linux has a number of mechanisms of varying capability and complexity for this purpose, but other kernels have taken a different approach. Over the last few months, OpenBSD has inaugurated a new system call named Unveil for this type of hardening that differs significantly from the mechanisms found in Linux. The value of restricting access to the file system from a security point of view is fairly obvious. A compromised process cannot exfiltrate data that it cannot read, and it cannot corrupt files that it cannot write. Preventing unwanted access is, of course, the purpose of the permissions bit user attached to every file. But permissions fall short in an important way. Just because a particular user has access to a given file doesn't necessarily imply that every program run by that user should also have access to that file.
Yeah, you have to take the case of a web browser into consideration nowadays, right?
Yeah, that can do a lot more stuff than just display websites. There is no reason why, for example, your PDF viewer should be able to read your SSH keys, for example. Relying on just that permission bits makes it easy for a compromised process to access files that have nothing to do with that process's actual job. In a Linux system, there are many ways of trying to restrict that access. That is one of the purposes behind the Linux Security Module, or LSM, in their architecture, for example. The SE-Linux LSM uses a complex matrix of labels and roles to make access control decisions. The AppArmor LSM instead uses a relatively simple table of permissible path names associated with each application. That approach was highly controversial when AppArmor was first merged, and is still looked down upon by some security developers. Mount namespaces can be used to create a special view of the file system hierarchy for a set of processes, rendering rendering much of that hierarchy actually invisible and thus inaccessible. The seccomp mechanism can be used to make decisions on attempts to process to access files. But that approach is complex and error-prone. Yet another approach can be seen in the Cubes OS distribution, which runs applications in virtual machines to strictly control what they can access. And compared to many of the options found in Linux, Unveil is an exercise in simplicity. The system call, introduced in July, has this prototype. So it returns an integer, it's called unveil, and it has two parameters. A const character path pointer and a const char pointer to permissions, or for permissions. A process that has never called unveil has full access to the file system hierarchy, modulo the usual file permissions and any restrictions that may have been applied by calling pledge. Calling unveil for the first time will drop a veil. Oh, that's where it's coming from? Okay. Will drop a veil across the entire file system, rendering the whole thing invisible to the process, with one exception. The file or directory hierarchy starting at that path will be accessible with the given permissions. So the permission string can contain any of R for read access, W for write, and X for execute, and C for the ability to create or remove the path. Subsequent calls to unveil will make other parts of the file system hierarchy accessible. The unveil system call itself still has access to the entire hierarchy, so there is no problem with unveiling distinct subtrees that are, until the call is made, invisible to the process. If one unveil call applies to a subtree of a hierarchy unveiled by another call, the permissions associated with the more specific call apply. So they don't cancel each other out. And calling unveil with both arguments as null will block any further calls, setting the current view of the file system in stone. Calls to unveil can also be blocked using pledge. Either way, once the view of the file system has been set up appropriately, it is possible to lock it so that the process cannot expand its access in the future should it be taken over and turn hostile. Unveil thus looks a bit like AppArmor in that it has a path-based mechanism for restricting access to files. In either case, one must first study the program in question to gain a solid understanding of which files it needs to access before closing things down, or the program is likely to break. One significant difference, beyond the other sorts of behavior that AppArmor can control, is that AppArmor's permissions are stored in an external policy file, while unveil calls are made by the application itself. That approach keeps the access rules tightly tied to the application and easy for developers to modify, but it also makes it harder for system administrators to change them without having to rebuild the application from source. One can certainly aim a number of criticisms at unveil, all of the complaints that have been leveled at a path-based access control and more. But the simplicity of unveil brings a certain kind of utility, as can be seen in a large number of OpenBSD applications that are being modified to use it. OpenBSD is gaining a base level of protection against unintended program behavior. While it is arguably possible to protect a Linux system to a much greater extent, the complexity of the mechanisms involved keeps that from happening in a lot of real-world deployments. There is a certain kind of virtue to simplicity in security mechanisms. Well said.
Yeah, Capsicum is, and FreeBSD is kind of similar. Once you enter the sandbox, you can't see any of the global namespace, any of the file system at all. However, if you opened certain directories or files before you entered the sandbox, you get to take those with you. And there's a call open at, where you can open a file that's somewhere below the directory file descriptor that you brought in with you. But making some kind of shim to provide more unveil-like functionality to the way Capsicum does it would be interesting. Basically, where you do this open call and basically you use something like unveil to give Capsicum a list of paths that you want the application to have access to, and then some kind of wrapper so that when it tries to open a file, we compare it against those paths and basically do what the unveil system call is doing. but doing that maybe in the Capsicum helper instead.
Like a whitelist for file systems. Or
yeah, that's basically Unveil is building that whitelist, but it's building it, I think, in the kernel as part of the process, whereas this helper thing, I think, would stay in user space and would just be converting your attempt to open a file in one of these allowed paths to turning it into a relative open based on the directory descriptors you've already opened.
Yeah, so you don't have to, if you make changes, you only make changes to that file rather than having to compile the application again.
Yeah.
Okay, yeah, sounds good. So we'll see more about Unveil in OpenBSD, I'm sure. And that's a good overview article from the Linux perspective. But I think it's good to compare these. I mean, a lot of these, if you look at this how-tos nowadays, the first thing that they do is please disable SE Linux, AppArmor, and all these other security tools so that the application can even run. Okay. Well, next up is the NetBSD Virtual Machine Monitor.
Ooh, yes. Cool. So NetBSD is getting its own hypervisor now to try to keep up with FreeBSD and OpenBSD. So the NVMM driver provides hardware-accelerated virtualization support on NetBSD. It is made from a machine-independent front-end to which a machine-dependent back-end can be plugged. So the idea is that you'd have a different back-end for, say, AMD 64 versus ARM 64 or whatever. A virtualization API is provided in libnvmm, which allows to easily create and manage virtual machines via the NVMM system. 2 additional components are shipped as demonstrators, ToyVirt and SmallKern. The first being a toy virtualizer that executes in a VM in a 64-bit ELF binary given as an argument, and the latter as an example of one such binary. So with their toy virtualizer, you boot in just one application basically as if it was a kernel. And then they give you an example SmallKern to do that with. So the source code and all the tools is available for download here on their MoonBSD website. So it says currently NVMM can support up to 128 virtual machines, each having up to 256 virtual CPUs and 4 gigs of RAM. So not for big virtual machines at this point. Each virtual machine is granted access to most of the CPU registers, like the general purpose registers, the segment registers, control, debug, FPU, and several MSRs. Events can be injected in the virtual machines to emulate device interrupts. A delay mechanism is used and allows VMM software to schedule the interrupt right when the vCPU can receive it. And non-maskable interrupts can be injected as well and use a similar mechanism. Currently, the host must always be x86-64, but the guest has no constraint on the mode, so you can also run 32-bit, so i386, PAE, real mode, and so on. The TSC, which is the clock, for each vCPU is always rebased on the host CPU as it is executing, and is therefore guaranteed to increase regardless of the host CPU. However, it may not increase monotonically because it is not possible to fully hide the host effects on the guest during a VM exit. So that's when the VM execution passes back to the userland application that's actually executing the virtual machine. That's when it switches out of hardware virtualization mode and into a regular C program where the hypervisor has to do some bit of work that the CPU can't do for it. Anyway, when there are more virtual CPUs than you have real CPUs, or more than the host translation look-aside buffer can deal with, NVMM uses the shared ACID and flushes the shared ACID vCPUs on each VM switch. The different interrupts are configured in such a way that they cover everything that needs to be emulated. In particular, LAPIC can be emulated by VMM and software, but intercepting reads and writes to the output page in memory and monitoring changes to the CR8 register in the exit status. And so currently, one backend is currently supported, using x86-SVM for x86 AMD CPUs. So currently, the NetBSD one only works on AMD CPUs, which is interesting because most of the other platforms, Intel came first and then AMD came eventually, but I'm guessing in this particular case, the developer doing the work happens to have an AMD. Okay, next story. What dependency actually means in Unix, as far as the init system is concerned, is technically unspecified.
Oh, what does that mean?
Our friend Chris Cyberman was writing on his blog, and he says, I was reading Davin McCall's on the vagaries of init systems, which there's a link to that, when I ran across the following about the relationship between various daemons or services. I do not see any compelling reason for having ordering relationships without actual dependency, as both Nosh and systemd provide for it. In comparison, dinit's dependencies also imply an ordering, which obviates the need to list dependencies twice in the service description. So he says, well, this may be an easy one, but it depends on what an init system means when it says dependency. Let's consider syslog or rsyslog and the SSH daemon. I want the syslog daemon to be started before the SSH daemon is started so that SSH can log things from the beginning. However, I very much do not want the SSH daemon to be started or to be shut down if the syslog daemon fails to start or stops after it's been running. If syslog fails, I still want the SSH daemon to be there so that I can perhaps SSH in and fix the problem. This is generally true of almost all daemons. I want them to start after syslog so that they can syslog things, but I almost never want them to not be running if syslog failed to start or to be killed off if syslog stops. And he says, and if for some reason syslog is not configured to start, I want enabling and starting, say, SSH to also enable and start syslog for me. So he does kind of want a dependency as well, but a soft dependency rather than a hard dependency or something. So he says, in general, there are three different relationships between services that he tends to encounter. A hard requirement, where service B is useless or dangerous without service A. For instance, many NFS v2 and v3 daemons basically don't function without the RPC port mapper being alive and active. On any number of systems, firewall rules being in place are a hard requirement to start most network services. You would rather your network service not start than for them to be online with no defenses in place. Or version B of this is it's a want rather than a requirement, where service B wants service A to be running before service B starts up, and service A should be started even if it wouldn't otherwise be, but the failure of A still leaves B functional. Many daemons want syslog to be started before they start, but will run fine without it. And often you want them to do so with at least some of the system works, even if there is, say, a corrupt syslog configuration file that causes the daemon not to be able to start. But some environments want hard fail if they can't collect security-related logging information. So they might make syslog a requirement rather than a want, but probably not the default. And lastly, an ordering, where if service A is going to be started, B wants to start after it, or before it, whatever. But B isn't otherwise calling for A to be started. We have some of these in our system where we need NFS mounts done before cron starts and runs people's @reboot scripts that might depend on files that live in NFS, or explicitly want each other or something. So the system as a whole wants both, but they're not strictly dependent on each other.
Yeah.
So given these different relationships and the implications of what an init system should do in different situations, talking about dependencies in a system is kind of underspecified. What sort of dependency? What happens if one service doesn't start or fails later or can't start? My impression is that generally people pick a want relationship as the default meaning for dependency. Usually this is fine. Most services aren't actively dangerous if one of their declared dependencies fails to start. And it's generally harmless on any particular system to force a want instead of an ordering relationship, because you're going to start everything anyway. In this example, you might as well say that cron on the system in question wants NFS mounts. There's no difference in practice. We always we already want NFS to start, and we want cron to start. So you don't need to list it specifically as an ordering thing, because a want will work. But maybe it makes sense to actually write that down correctly.
Yep. No. It's a good thing to distinguish that and defining what really dependencies mean and how hard they are or how soft. So another thing that we have here is jailing the bhyve hypervisor. And this is an article by Sean Webb here. FreeBSD nears the final 12.0 release engineering cycles, I'd like to take a moment to document a cool new feature coming in 12, jailed bhyve. You may notice that I use HardenedBSD instead of FreeBSD in this article. There is no functional difference in bhyve on HardenedBSD versus bhyve on FreeBSD. The only difference between HardenedBSD and FreeBSD is the additional security offered by HardenedBSD. The steps I outline here work for both FreeBSD and HardenedBSD. These are the bare minimum steps, no extra work needed for either FreeBSD or HardenedBSD. And it continues with a gentle history lesson. At work in my spare time, I'm helping develop a malware lab. Due to the nature of the beast, we would like to use bhyve on HardenedBSD. Starting with HardenedBSD 12, no cross DSO, CFI, SafeStack, Capsicum, ASLR, and strict write XOR execute are all applied to bhyve, making it an extremely hardened hypervisor. So the work to support jailed bhyve is sponsored by both HardenedBSD and my employer. We've also jointly worked on other bhyve hardening features, like protecting the VM's address space using guard pages with nmap and the map guard parameter. Further work is being done in a project called malhyve. Oh dear. Only those modifications to bhyve/malhyve that make sense to upstream will be upstreamed. So here's the initial setup. We will not go through the process of creating the jail's file system. That process is documented in the FreeBSD handbook. And for UEFI guests, you will need to install the UEFI-EDK2-bhyve package inside the jail. I network these jails with traditional jail networking. I have tested VNet jails with this setup, and that works fine too. However, there is no real need to hook the jail up to any network so long as that bhyve can access the tap device. In some cases, the VM might not need networking, in which case you can just use a network-less VM in a network-less jail. By default, access to the kernel side of bhyve is disabled within the jail, and we need to set allow.vmm in our jail.conf entry for the bhyve jail. We will use the following in our jail, so we will need to set up defs rules for them, a ZFS volume, a null modem device NMDM, UEFI GOP, no defs rule, but IP assigned to the jail, and a tap device. So here goes the description.
Yeah, so basically, inside the jail, you're going to set it up so that A, they have access to the bhyve stuff so they can create the VM, a tap device so that they have something for the VM to talk on the network with, the null modem device so you can access the serial console, a zvol so that they have some storage to have access to, and then lastly, an IP address so that when you're listening on VNC, you have an IP address to listen on.
Yeah, that's pretty straightforward. And so in conclusion, the bhyve hypervisor works great within a jail. When combined with HardenedBSD, bhyve is extremely hardened. PAX ASLR is fully applied due to compilation of a position-independent executable, and that's a HardenedBSD enhancement. The PAX no exec is fully applied with a strict write or XOR execute, which is also an HardenedBSD enhancement. All of the next ones are too. Non-cross DSO CFI is fully applied. Full rel RO plus bind_now is fully applied. SafeStack is applied to the application. It's jailed, of course. That is a FreeBSD feature. Yeah, pretty much since forever. And virtual memory protected with guard pages as well as Capsicum is fully applied. Bad guys are going to have a hard time breaking out of the userland components of bhyve on hardened BSD.
But yeah, with the jail guard pages and capsicum available on vanilla FreeBSD, they're already going to be stuck in a jail in a process that can't read any files.
Yeah, that's already something. Yep.
So there's not much of a VM escape left at that point.
Yeah, definitely something to look forward to in 12, if not just other features. Okay. So, time for the BSD bits this week. We have finally GhostBSD 18.10 been released. Remember, a couple of shows ago, we just announced RC2 and I think RC3, but now it's out there in its fully freshed released version, and you can grab it without any RCs attached to it.
Yeah. So now GhostBSD is based on TrueOS instead of vanilla FreeBSD. It uses OpenRC, LibreSSL, and a bunch of things like that. The GhostBSD system can now be upgraded using TrueOS-based packages. Removed grub in favor of the FreeBSD hybrid loader. Network Manager now supports managing multiple network card connections. They removed UnionFS from the live session so it doesn't crash all the time. They've made a number of other changes to the live system, fixed many issues. GhostBSD now can boot directly into a mate session, and it supports ZFS boot environments by default. It does note that the vanilla FreeBSD ports and packages trees are incompatible with GhostBSD, the new version, so you want to use the TrueOS versions. And they've added the DRM Next K mod so that the latest AMD and Intel graphics drivers are available. And they've added the libva Intel driver and libva VDPAU drivers to support accelerated video playback on some Intel cards, and the NVIDIA driver has been updated.
Ah, nice.
Nice.
Yeah, it would be cool if...
Big thanks to IX Systems, TrueOS, and the number of people he's been working with to get this done. Yeah.
Download it, try it out, see if it works for you, how you like it, and well, let us know, or let, of course, them know, because they deserve all the credit.
Speaking of that, more the next news. One is Project Trident, the successor to TrueOS, as a desktop OS, basically, has release candidate 3 now available, which is actually based on FreeBSD 13. The default bootloader is now the FreeBSD Lua-powered bootloader. So there's fixes many issues and makes it easier to script and so on. The name prefix on the base packages has been changed from FreeBSD- to just OS-, so that you can, mostly I think because they're doing the same thing on TrueOS, GhostBSD, Trident, etc., it makes sense to just have one prefix. The packages are aligned with the TrueOS ports tree as of November 3rd, and the number of default system configuration settings are no longer getting set up properly with the new base of TrueOS. These are mentioned in the errata section on the download page, and you might need to fix those, but they're expected they will be fixed in RC4.
Mm-hmm. All right.
So if you're interested in Trident, check it out.
Yep, certainly. And our next item is also good news. The OpenBSD Foundation receives the first silver contribution from a single individual, and not just some random guy, but, drum roll, John Carmack.
Well, if you remember, over the summer, we covered an article of his where he went off to a cabin with only a laptop and OpenBSD and wanted to write some, I think it was machine learning code or something. Just, he wanted to write some code and found that OpenBSD was a nice development environment for that, because it provided a nice set of constraints to keep them from going off topic too much.
Sure. And yeah, this made him like the system apparently, otherwise he probably wouldn't have donated. So thanks for that generosity in the OpenBSD's coffers. Yeah, great.
So next up, we have an interesting one. So this one's taking the Gorse tool, which we've talked about a little bit before, but is actually meant for looking at commit logs in Git or SVN or whatever. And we've used that before to visualize the FreeBSD source tree. But in this particular case, they're hooking it up to the pflog device and actually showing what's going on in your firewall in a moving graphical interface.
Oh yeah, so you can see
this post demonstrates how to use Gorse to visualize PF firewall logs. So having organized a couple capture the flag competitions in the past, we looked into ways of providing the bystanding audience some visual something to look at and informational stream regarding the competition progress and player activity. Back when we were preparing the ATHCon CTF, we came across the cool way to visualize our CVS history using Gorse. Poking around in Gorse, we realized it supports a custom log format as input, and then it hit us. We could transform network activity data into pipe delimited format to create an impressive visualization of real-time activity on the wire. So today, this technique is impressively useful to monitor packets that are being logged by their PF. So in the firewall rules, they just add a block log line that will basically block every packet and log it. Note that when logging match or pass rules, only the initial packet in each connection is logged unless log all is written or no state is specified. Otherwise, packets that match a state rule don't get logged. The standard way to monitor these packets is running something like TCP dump against the pflogd device or directly accessing the pflog device as well. So they show either you can look at the pflog file or actually connect to the pflog interface.
Very cool.
And so then they show what it looks like, and it looks like a cross between a disco ball and a snowflake, actually.
Yeah, there's a lot of things happening there.
Yep. So they have timestamp, username, type, the file, and the color. And they wrote a little awk script that converts the TCP dump output into that Gorse version. And when they put it together, you can see what people are doing. So this is the simplest visual you can get from pflog activity, creating a new branch hierarchy of attacked host and port on each host. This is by no means complete, but leaves a lot of options to customize. And then you can keep tweaking it. And they did some other stuff, and they're getting a list of the people over at the side here. And then you can see the host clusters and the IP addresses and so on, and port numbers. And so they actually have a little video here. And you can see this demonstrates what it looks like when doing an Nmap port scan about halfway into the video here.
This is what you would see if you see like a movie where they say, oh, look, let's look at this cool networking stuff in between at the sysadmin screen where you show this animation and you say, oh, wow, this is so cool. And everyone is like, well, I can create that in 5 minutes.
Yeah, and each of the attackers is one of these little silhouettes of a person floating around, and then they're shooting lasers at port numbers
pew,
on
pew.
hosts. And yeah,
they're attacking us. Yeah, let's block it at the firewall. And yeah, so you can see that there's a lot of interesting things you can do with a tool that was originally not written for that kind of visualization.
No, it's meant to visualize the repo, but it makes sense to apply it to the network.
Speaking of network, we have a news over from the Twitters that NetBSD is now running on RISC-V, or is alive at least, by Zachary McGrew. He tweets, NetBSD on the RISC-V is alive. Well, PID1 is running and hungry for a root file system at least. So you can see a screenshot here.
Making progress.
Yeah. Almost there. Yeah, great. More NetBSD on more platforms.
Yep. So now we have a post by Theodore Ratt on the OpenBSD tech list about the security advisory for X. So he says, in his role at X.org in the security team, Matthew says he became aware of a bug on the 11th I'm guessing of October, because this is post was from October 25th. They note, he did not tell any of us at OpenBSD. We were made aware a bit more than 1 hour before public information went out. We were in the midst of the early OpenBSD release. If we had known, the OpenBSD 6.4 release could have been held back a week or two until, say, today, and it could have been easy, or even easier. We could have made the late decision to disable legacy drivers and lose the setuid bit, which will probably happen in a commit later today. But we were not made aware. Therefore, OpenBSD 6.4 is affected by this vulnerability. As yet, we don't have an answer about why our ex-maintainer or the ex-security team and the rest of the team provided information to other projects, some who don't even ship with this X server, but chose not to give us a heads up, which could have saved all the new 6.4 users from a lot of grief. I don't understand how it's happened. From my point of view, we all share a goal of getting fixes and preventative methods out to the community as fast as possible. Here, an artificial delay was created, which left a trivial vulnerability known to the upstream on everyone's machine in an operating system with a well-known and published release cycle. I feel an abdication of the duty of care occurred here. It is the first localhost root hole in quite a long time.
Yeah.
And there don't appear to be any replies to this thread, which seems unusual for the OpenBSD mailing list.
Yeah. But it wasn't just an announcement. It's definitely discuss-worthy.
Yep.
Okay. Next up is announcing the package source 2018 Q3 release. So this is from October already, but still fresh.
A bit behind on that one, sorry.
The package source developers are proud to announce the 60th quarterly release of package source, the cross-platform packaging system. Package source is available with more than 22,000 packages running on 23 separate platforms. And of course, you can find more information at www.packagesource.org. So in total, 161 packages were added, 25 packages removed, and 1,321 packages updated to 996 unique packages. Those were processed since the package source 2018 Q2 release. So a lot new versions, Asterisk, Bind, Clang, Firefox newest version as of this writing, GCC, Go, Lua, MySQL, Nextcloud. So there's something for everyone. PHP, of course.
The big change is that Go packages are now versioned, similar to how FreeBSD has done it in the past. Instead of lang/go, you have lang/go 19, 110, and 111 to cover 1.9, 1.10, and 1.11. Depending on the OS, an appropriate version is chosen as the default, and they can be installed simultaneously. So you can actually have 2 or 3 versions of Go at once if that's what you need.
Oh, cool. And a message was sent by Jonathan Perkin from Joyent. So I see they are using and working with package source.
Yes, so they needed a modern userland for SmartOS, and it made sense to use the portable one.
Very nice. So grab that. And we have an article about NAT performance on Edge Router X and Lite with EdgeOS, OpenBSD, and OpenWRT. So, yeah.
It looks to be pretty much everything you need to do it, and they wanted to compare some stuff. So the way they did their test was running iPerf on their MacBook Pro, feeding that through their Juniper EX2200C through the device under test to an iPerf server running in a Debian VM. I'd caution against running network tests that involve VMs because there's all kinds of timing issues, and just virtualized network performance is often not the same as real network performance. But anyway, iPerf was used to test for 30 seconds at a time. I ran 3 tests per configuration, did some quick math. Seriously, there wasn't a lot of rigor used here, so you might want to take the results with a grain of salt. But comparing the different versions of EdgeOS that you might run on your Edge router, seeing EdgeOS 1.10.6 with hardware acceleration pretty much maxes out the network interface. But if you disable the hardware acceleration, you lose about 90% of the performance. Looking at EdgeOS 2, you see similar hardware accelerated performance, although maybe dipping a bit lower. But when you disable hardware acceleration, the results are even worse than before, less than half of what they were under 1.10. So that's interesting. Looking at OpenBSD, running without hardware acceleration, the results are more than double what you get on regular EdgeOS without the hardware acceleration. Comparing to OpenWRT, using its software acceleration, it was getting about 640 megabits, whereas with no acceleration, it was managing about 220 to 230. So a little bit better than OpenBSD 6.2.
Okay. The next one is interesting for the historians among us. Unix, as we know it, might not have existed without Mrs. Thompson. So this is over at princeton.edu, which makes it somewhat interesting source. Oh, UTF-8 fail.
Yeah, something with the apostrophes is all wonky.
Yeah, so this is an interview, basically, with her. Oh, no, with Ken Thompson. Here we go. And, okay, that's the interview here. And he mentions his wife. It's a long article. Oh, wow, it's a long interview. But in there is the mentioning that Mrs. Thompson was kind of responsible for making Unix.
Yeah, so when he talks about the summer of 1969, he says, "In fact, my wife went on vacation to my family's place in California to visit my parents. We just had a new son in August of 68, and they hadn't seen the kid yet. So they took the kid to visit my family, and she was going, or was gone a month to California, and I allocated a week each to the shell, the operating system, the shell again, the editor, and the assembler, and to reproduce, making the assembler able to reproduce itself. During the month she was gone, which was in the summer of 69, I was able to totally rewrite in a form that looked like an operating system with tools that were sort of known, like an assembler and an editor and a shell, if not maintaining itself, right on the verge of maintaining itself, and managed to do that." This seems to be some kind of transcript from an interview, because there's a bunch of bits where it says it's unclear what he was saying or whatever. But it's interesting that it only happened because he had all this free time.
Yeah. Otherwise, we would probably not got it.
I'm sure there's more to this reference, but sadly, our notes don't actually tell us which part of the interview to look at for that.
But it's certainly interesting as a historical tidbit.
Yes.
You don't get many interviews.
The interview itself is worth reading.
Yep. And we have free pizza, not we ourselves, but this is the announcement here. Free pizza for your dev events for people who are running like user group, meetup, hackathons, tech talks, conferences even. And if you want free pizza, you can get free pizza at www.freepizza.io. And sponsors want to give you free pizza. Nice. So you can see upcoming events you can pick by country. Germany is not among them, but Canada is. So let's see what's in Canada.
Germany would pop up on the list if somebody scheduled an event in Germany.
Oh, you mean yeah, okay. I know what you mean. But yeah, you can see who already... there's a lot of stuff already going on. This is not just BSD related, but still interesting enough for meetups or tech talks that have technical content of some sort. And you can order pizzas for those, or get pizzas, free pizzas actually, to those. And while we're on the subject of pizzas, there's the Portland BSD Pizza Night coming up in the 29th of November at 7 p.m.
Yep. So I think they meet once a month or once every couple of weeks. Anyway,
could be.
If you look at the calendar thing here, they'll have future ones available as well. And they go to a different pizza place every time. Apparently, they've been to like 40 some odd different pizza places so far.
Yeah.
I didn't know there were that many pizza places in Portland, but okay.
Well, now they can get free pizzas too. Just in case they don't get enough.
But have some pizza, sit around and talk about BSD. There are people from all the projects there. It's interesting, and I wish it was in my backyard. So if you're anywhere near Portland and you can go to this, you should. And then I will be jealous of you.
Yeah. Not just for the pizza, but for the good discussions.
Exactly.
Okay. That pretty much wraps up our BSD bits here, and going right into the feedback and questions sections, which we are still running a little bit low here. So if you have anything for us, then send it to feedback@bsdnow.tv so we have something to put into that section. Otherwise, we just have to ask ourselves. And yeah, it doesn't go well. So the first one is Dennis this week with a question about core developers leaving Illumos, ? He writes, "Hi, Alan, Jude. Nice to hear Michael Lucas talking about his books and his criteria on writing them in the other day's episode. Listening to episode 267, I was quite surprised to hear you mention just before 30 minutes in that half the core developers of Illumos would leave within half a year. I've searched the web several times in vain and looked into mailing lists, but haven't found anything to substantiate this. Why are half of core developers abandoning Illumos? Where are they going to?"
Well, I don't know that any particular developers are leaving Illumos, but there are a few companies that have been using Illumos for their products and are now switching to something else. It varies what they're switching to. Delphix, for example, is switching to Linux. That doesn't mean that Matt Ahrens is going to stop being an Illumos developer, just that his day job will no longer be paying him to write Illumos code all day.
Yeah, the companies are leaving, not the project members or the people working on it.
And not all the companies. There are still some there.
Sure,
but, some of them are leaving to use something else to build the product, and that will definitely have an impact on what Illumos looks like a couple of years from now.
Certainly. But maybe new companies will join that, so it's a coming and going.
They should use FreeBSD, though.
Well, yeah, that's their choice. But I hope that clears it up, and we can let that as it is.
Delphix has one or two blog posts where they talk about how they made the decision. It mostly came down to when they're hiring new young developers, Linux is what they know.
Nowadays,
which is a problem that we will have to try to fix, and it will take some time for that to actually work.
Yeah, there seems to be a learning curve coming from other operating systems.
Right. Well, the point is we have to get them exposed to BSD earlier so that...
Sure. Yeah, it's an ongoing
they're more aware
process
of what the differences are. Yeah, if you've seen a little bit of all of them early enough, you learn which things are specific to Linux versus what things are generic to all of them. And it helps you understand better. Yeah,
definitely. And it cannot be just Alan and myself. You can also tell other people about it. You can't do all the work alone.
We need the BSD Now army needs to parachute into all these Linux conferences and make sure that there's a BSD talk.
Yeah, giving a talk or giving a tutorial, telling people how nice you can work on the BSDs, whatever BSD it might be.
Give a presentation about BSD at your local Linux user group. Can be a good way to bootstrap a BSD user group, or just, commandeer it like they do in Portland.
Yeah. Just for the pizza. Okay, moving on to the next question from Ben about jumping from snapshot to snapshot. This one goes, "Hello all. Loving the show as always. It was great to hear Michael Lucas on the show last week. Sure, yeah, that was nice. We need more interviews. I've got a question about current, specifically the alpha and beta snapshots. Is there an easy way to jump from snapshot to snapshot? I want to help test the new release, but I don't want to periodically spend 3 to 4 hours building the system. Back in the BSD bits of episode 199, you mentioned the Mondieu tool. When you mentioned it, I got the impression that it was a cool tool you'd been notified about, but hadn't had time to evaluate yet. It's not had any attention in a year or so, but do you know if this could be a reliable way to jump between the snapshots? As I said,
you're definitely right that I've not had time to look at it. I don't know. I think with the betas, but if not with the RCs, you can actually use FreeBSD update to jump to newer ones. With the alphas, you can't. I've also previously written up at the beginning of a tool to jump from snapshot to snapshot, but I never finished it.
Yeah. But yeah, it's definitely good to help test because everything that we find in the betas is not going to make the release because all the bugs there hopefully will get fixed.
Right. But it makes it much easier to test the betas if you can just pop forward from one to the next. And I think FreeBSD update will work as long as you're starting from the first beta or later.
Yeah, it needs a bit of time to build actually that and distribute those packages or the updates.
The FreeBSD update things will be available within a day or so of the beta snapshots themselves going on the FTP site. I don't know exactly how it works for like a major release like this, a .0. I'm pretty sure with the point releases, the betas are definitely FreeBSD updatable.
Yeah, that too.
I think the betas are though.
Maybe someone else knows about a cool tool that does that or has written one just for that purpose. Let us know. And last in our frequent questions this week is a question about ZFS snapshots. Oh, here we go. Hi, Alan and Benedict is this one. I have a question about ZFS. At the current time, I only do snapshots of my datasets manually. Then I manually ZFS send and receive them to a backup pool. I'd like to keep all the snapshots going as far back as possible on the backup pool, since it has plenty of space. However, I'd like to thin out some of the snapshots on the source pool for space reasons. I know where this is going. I'm just wondering if there are any things I need to look out for if I do this. Suppose my dataset is named My Data, and I have snapshots at January, February, March, and April on both the source and backup pool.
Okay, just first thing, you might want to put the year in there, because eventually it's going to be January again.
Sooner rather than later, yeah. Christmas comes off in a year. But yeah, I could theoretically delete January, February, and March snapshots in the source, generate a new May snapshot, and then send an incremental update from April through May to the backup, right? Correct. You could summarize this question as, do I only need the latest 2 snapshots to be able to send an incremental update via ZFS send and receive?
Yes, although I might keep one more to be more safe. The other thing is there's a trick. Before you delete the January and February and March snapshots, if you use the bookmark command to turn them into bookmarks, the starting point of a ZFS incremental replication doesn't actually have to be a snapshot. It can be just a bookmark. So bookmark is literally just the transaction number of the snapshot, but it doesn't keep the old copies of the data. So you can't roll back to a bookmark, but you can use the bookmark as the point for an incremental replication. And this way, if somehow the backup pool ever gets out of sync and is missing, doesn't have a common snapshot with the current pool, maybe you'll have a common bookmark that you can use. And you can say, send everything from January up to this point as a send stream. So yes, convert them to bookmarks before you delete them. And I would try to keep at least 2 snapshots in common between the local and the remote, and I would automate this. I do basically exactly this, but with snapshots every 15 minutes. Those are replicated, and then we only keep... the backup only keeps snapshots that exist on the primary, unless the snapshot is more than 3 months old, then it's protected, and we keep the old ones on the backup that way. So I don't keep every 15-minute snapshot on the backup, because then it would just get to be tens of thousands of snapshots, and it would take forever to do ZFS list-t snapshot. But I can keep 1 snapshot a month for forever or whatever. Exactly.
Yeah, and bookmarks makes it small enough and tells basically ZFS, hey, next time you start from here. And
well, the bookmark is more. It's a point in time that you have as a bookmark, basically. So, I need every block that's newer than this. And any block that was changed after the date of the bookmark needs to be part of the incremental send.
Yeah. But the message goes on. Here's a trickier scenario. I suppose I started with the same 4 original snapshots, but then destroyed February and March on the source data set to thin out the source pool a bit, leaving January and April. Then suppose a lightning strike took out both of the disks in my backup pool, but left my source pool undamaged. This sounds relatively specific here.
Well, no,
unlikely.
It's very easy to get out of sync like this.
Yeah. Unlikely, I know, but perhaps it was turned off at the time. So now I want to create a new backup pool on a new hardware and send it all the data that still exists on the source. Of course, I can send the entire January snapshot to the new backup, no problem. Can I still send an incremental backup of January through April successfully?
Yes.
You could summarize this question as,
Continue.
Yeah, you can do that. Yeah, will an incremental send and receive still work if you destroy some intermediate snapshots between them?
Yes, because in ZFS, it only basically needs 2 transaction numbers or 2 dates. And it just says any block that's modified between this date and this date needs to be sent across. And it just goes through the pool and sends every block that's been changed in that time.
Yep, that's the beauty of ZFS, making that possible
and
without...
This is why I recommended that you keep at least 2 snapshots on the source side. Because if you had only April, then it'd be you wouldn't have as much of a backup, and you wouldn't be able to roll back. And
stay on the safe side.
Way, whatever happens, you'll be okay. Mm-hmm. And this would still work if your January snapshot was only a bookmark. You'd still be able to append to the January snapshot that existed on. Or sorry, if January was only a bookmark, you would only be able to send all of April. But if your backup had January but nothing else, you'd be able to incremental from January all the way to April. But yes, the important part with ZFS for incrementals is you can go from any 2 snapshots or from any bookmark to a snapshot. It doesn't matter if there are ones in the middle or not. In fact, when you do ZFS send, depending whether you use the lowercase I or the uppercase I, you can say from here to here, send every snapshot between that, or only send the 2 that I picked and skip the ones in the middle.
Yeah, you can read about these.
Which way you like.
Sure. Yeah, you can read about these snapshots and bookmarks in the second ZFS book that Alan and Michael Lucas wrote. Yep. So there's the examples in there you can understand and try them out on a test pool and see how it works if you delete stuff on the source. And yeah.
But yes, biggest recommendations. I'm sure you just did it to make it simpler for the email, but when naming your snapshots, I would put year, month, day in it because otherwise...
Where's my last year's January?
Well, so I have this thing where I replicate my SVN tree or Git tree over to my laptop before a conference. Well, I can't just call the snapshot BSD can because there have now been 4 BSD cans for that ZFS dataset.
Same thing. Every year, the same date, the same occurrence.
Yeah.
All right. That wraps up the feedback and questions section as well as the show. Again, if you have something for us, blog post, something interesting in the BSD world, show ideas, comments, send all of that to feedback@bsdnow.tv and we'll cover it in a future episode. Thanks for watching.